Alright, first off, I am going to hack this name because I don't know how to say it. I think it's Demoivres or something like that. It's French, so pardon my French. But that is... all of these theorems are actually contributed to him, or at least he's given credit for them. This is most commonly called his theorem, though. It's the power. So if I take a polar form and I raise it to a certain power, we use this formula. Now, this makes sense based on the law of multiplication that we would multiply the r's, right? If I had a couple z's, a couple polar forms that I'm multiplying, I would multiply their r's. So if they're all the same, that's the same as saying r to some power, right? Whatever power that is. And then if all the angles are the same, right? An exponent is repeated addition. So I'm sorry, multiplication is repeated addition. So if I have an angle that I continue to add however many times, right, n times, then that's the same as n theta. So the formula is pretty easy to use. Let's look at the first example, how to use it. So we take z to the fourth, and we take our r, and in this case, I don't have an r, right? It's just 1, so 1 to the fourth, and then cosine 4 times 70 degrees plus I sine 4 times 70. And again, I'm showing kind of the long way, but I do think many of these can just be done directly to that shorthand formula. So z to the fourth is just cosine 280 degrees plus I sine 280 degrees, or CIS 280 degrees. All right, pretty straightforward. This next example, I wanted to elaborate a bit because, like, a lot of what we are doing is just making long computational things to do with imaginary numbers simplified by going into polar form. So it's just another way of expressing many of these values using trig. So this one in particular, z squared, it really wouldn't be too bad without making a conversion, right? All I'm saying is take this and square it. But what if I had asked you to do to the 10th power? Well, z squared is only, right, 2 root 2 plus 2 root 2i, and then squared, so multiply by itself. Or you could use the binomial formula. But applying FOIL here, right, to a squared really isn't bad. But z to the 10th, I would need to write this factor 10 times out and multiply it. Yeah, I could probably develop a couple shortcuts, but still it would take forever. Alright, so what we will do is convert it to polar and then apply the theorem. Now, just to verify we do in fact get the same answers, let's go ahead and distribute and do it algebraically as well. So 2 root 2 times 2 root 2 using FOIL, we would have 4 times 2. 2 times 2, and then root 2 times root 2 is 2. Now, 2 root 2 times 2 root 2i is again 4 times 2, which is 8, so 8i. And then I would get another 8i. And then last I would get 8i squared. Okay, so we have 8 plus 16i, and then I squared is negative 1. Oops. So negative 1 times 8, so negative 8. So we get 16i. All right. Now let's do polar form and then apply de Moivre's theorem and verify that we do in fact get 16i. Okay. So first step, we need to know what r is and what theta is. So r recall, let me go and switch colors here. R is the square root of a squared 2 root 2 squared plus b squared 2 root 2 squared. Well, again, both of these are 8. We just did that here, right? 2 root 2 times 2 root 2 is 8. So plus 8, and that square root is 16, which is 4. Now to get theta, again, you could use cosine theta or tangent, whichever trig function you want. I'm just going to stick with tangent. Theta is b over a, 2 root 2 over 2 root 2, which is 1. And the angle that gives me tangent equivalent to 1 is pi over 4. And again, we could have done a quick sketch to kind of verify that, but if a and b are both the same, right, that's a 45-degree angle, or pi over 4. All right. So therefore, we have z equals r cis pi over 4. Do one more color here. So therefore, z squared, again, applying the formula, it says to do r squared, 4 squared is 16, and then cis and theta. I'm going to use the abbreviation once, but then we're going to expand it because we are verifying that we do in fact get 16i. All right, so cis and then 2 times pi over 4, right, and theta. So 2 times pi over 4 is pi over 2, and 4 squared is 16. So I'm going to go ahead and write the expanded version, cosine pi over 2 plus I sine pi over 2. Now, I didn't create a video about how to go from polar form into just complex form, because it's very straightforward. All you do is you evaluate cosine pi over 2 and evaluate sine pi over 2. If they are not exact values from the unit circle, all the angles we memorized, then you'd have to use a calculator if you wanted it in complex form. So cosine pi over 2, right, that's the x value, we get 0. And then sine of pi over 2, we get 1. Now we have this 16 on the outside, so when we distribute, right, 0 plus 1i, we just get 16i. And it matches what we had above. Good to go. Now, if we weren't really evaluating and checking our answer, right, we would have just left it as 16 cis pi over 2. But you can't immediately tell, right, if you didn't put it in the trig form like this, the polar form, couldn't immediately tell that you do in fact get the same answer. And again, one more time, what is the benefit of doing this? Say we had c to the 10, this would be really easy to compute, right? All I would need to do is change that exponent to a 10 and get a calculator, because 4 to the 10th is huge, and then multiply the angle by 10.